Hi, good morning class. Today, myself, Jeline, Dahe, and Aaron will be presenting on ISM Library with regards to their book request service. Our flow unit for this book request service would be student, and the resources consist of student, one librarian, computer database, and books. And the input will be student request and the output will be completed student book request. As you all know, if you have actually been to you have actually used a book request service, okay, you actually know that the library actually follow a single channel system based on first in first out basis, and every arrival waits to be served regardless of the length of the queue, and arrivals are actually independent of the other incoming queues. So service time actually varies for student to student based on the request that they are making. This is our book request service process map. Okay, the student will first send in a request, and then the librarian will then process the student request. If let's say the student is actually looking for a book, the librarian will actually check for book availability via the booking system. And if let's say the book is in the library, the librarian will locate the book, check out the book, the student will exit from the system. Else, if the book is not in the library, the librarian will actually check for the next possible date on the system, and then if let's say the student choose to go ahead to reserve the book, librarian will inform the student of the next possible date to actually pick up. The student will exit from the system. And if the student choose not to reserve the book, the student will also exit from the system. And if let's say the student is actually not looking for a book, okay, most likely the student is there to actually return a book, then the librarian will actually update the system status, and then the student will then exit from the system as well. Our goal of improvement for this book request service is to actually facilitate queue and reduce any waiting time during lunch hours, because lunch hour in ISM is actually fixed and time is critical for all. And also, furthermore, there is only one librarian during lunch hour, so it is very important for us to look into this process and make any possible changes if possible. And this is the measurement that we took during the lunch hour. We have the inter-arrival time and the processing time. So based on these values, we will actually be using it to come up with calculation later on, which we will explain in further detail. And we have actually plotted out the data on the Excel sheet for the students in the arrival and processing time. You can actually tell that those yellow bars are when the librarian is actually occupied, busy helping out with the processing of student requests, and at a certain time interval you can see that the librarian is actually idle, doing nothing. Okay, so with all this data that we have on hand right now, we are going to use the queue length formula to actually analyze the process performance, because based on the inter-arrival and processing time, it is actually not known and constant, as it is subjected to the effect of variability. Okay, also variability in processing time is actually independent. It's not related to the inter-arrival time. We cannot interchange the service processing time across the student arrival time and achieve synchronization to reduce their waiting time. Therefore, queue length formula actually helps to give an approximation of the average queue length based on the variability effect of both the inter-arrival and processing time, as well as the capitalization effect during the process. Okay, so over here, once we have got the data, we have to first of all we have to compute the average rate for supply and demand. Supply in this case refers to the inter-arrival time that the students actually come in for service, and the demand is for the service. So we have inter-arrival time, which is 4 minutes per student, and average time for processing time for service is 2 minutes per student. And then with the average inter-arrival time and processing time, we are able to compute the capacity utilization effect to see how efficient is our resources actually being utilized. So for the average arrival rate is actually Ri, which is equivalent to 1/4, and average processing rate is Rp, which is equivalent to half. Okay, we know that Ri is actually smaller than Rp. Okay, 1/4 is definitely smaller than half. So therefore, our throughput rate is to take the smaller R, which in this case is actually Ri 1/4. So to calculate capacity utilization, we take R divided by R/P. So we have 1/4 divided by 1/2. We have 0.5. the max capacity utilization is actually 1. So with 0.5, you know that in this case for the library, the resources is only half utilized. Next, for the Q-length formula, we have to proceed on to calculate the coefficient of inter-arrival time. So first of all, we have to compute the average, which we have done earlier on, which is 4, and then obtain the standard deviation based on the calculator, which is 3.281. So for coefficient, right, you have to take the standard deviation, divide by the average. In this case, we have 0.82 for coefficient for inter-arrival, and similarly for the coefficient for processing time, we have 0.64. With that, right, we apply the Q-length formula to find out the input inventory. So therefore, on average, right, there will actually be 0.2705 students waiting in line at any point of time. And then once we have calculated the input inventory, we are able to find out the average time that a student will actually spend in queue. Okay, if you still remember Litter's law, okay, Q-length formula, you can actually use it to compute further on, like using the same way like how you calculate Litter's law. So average time, we take T equal I, time in inter-arrival equal to input inventory over divide by R. So we have 1.082 minute. So on average, a student actually spend 1.082 minute in queue. And the average time that students spend in processing is actually 2 minutes. So on average, the total time each student spend in the process is actually 3.082 minutes. And for inventory, right, once we have computed the total time and we have the rate, which in this case is 1/4, you are able to calculate the inventory. So on average, the total number of students in the process is only 0.7705. It's not even equivalent to 1. Okay, and then for throughput rate, right, we know the average rate that a student is being processed, but to find out if, let's say, the resources is actually being properly utilized, we can find out what based on the throughput rate of the safety capacity. Okay, in this case, we obtain 0.25 minutes. From the computation, right, you can tell that there is actually sufficient processing capacity to handle the inflow rate. Based on the data computed, capacity utilization is only half of the resources provided. In this case, earlier on we mentioned it's only 0.5. And having one more librarian at the counter, we have C equal to 2, referring to 2 librarians. Okay, the capacity utilization is reduced to 0.25. And although it is further reduced to half, however, with sufficient processing capacity of 0.5 to handle the inflow rate, it is not necessary to increase the number of librarians at all. And during lunch hour, from a business point of view, resources are not fully utilized. What the upper level could actually do is to actually assign administrative related issues to the librarian. And also right now, right, since students are able to check for the book availability and make reservation via the library portal, it helps to facilitate the whole process. Therefore, there is no need for additional librarian allocated during lunch hour. And because right now it's near the end of the semester and demand for book service could be low. Okay. However, during the start of the semester, there could be a possibility of queue forming up as students needed textbooks. So one way to improve is that you can improve features on the library portals that facilitate the collection of books. Or else, it could also be possible to hire temporary staff to reduce the number of queue. And plus, if you actually choose to hire one more librarian, over the long run, you will actually incur more costs. So there is no need to do that at all. So that's all for our presentation. Thank you.